I still think there is something missing. And there is something missing about the pigments, about the properties, about what is in chemistry in the trees. Because in the end, hyperspectral remote sensing is like chemistry from space. And this is missing if you just look at structure. You look at time with Sentinel-2, you look at structure with orthophotos, but you still miss the chemical properties of the species. And I don't say it's impossible to do it with orthophotos, deep learning, and Sentinel-2, but it's definitely better with hyperspectral. But if we come to that, wouldn't it be better to include LiDAR data? Because LiDAR took over the whole remote sensing forest community in the last few years. Is there any possibility to merge hyperspectral and LiDAR to get to better results? Not just on tree species discrimination, but also on vitality, on future management of forests?
There's maybe a certain chance that laser scanning can really help now with respect to the species topic, potentially also with respect to if you want to, for example, derive leaf pigments chemistry, because you could get let's say an additional estimate of leaf area that is related also to the density of the point clouds and of the airborne laser scanning system. So I do see a certain value there, but of course it's super expensive, and I think this is a bit the bottleneck that we face, because if you just fly LiDAR, it's already quite expensive. People do it because it's worth it. It's very stable signal. But if you fly LiDAR and hyperspectral, you have at least double the cost. Maybe it's too much, but hyperspectral is really expensive. So I think this is a bottleneck where I'm not sure whether we will be able to address this in the future. Because maybe we will, but my feeling is in the last 15 years or so, like when I wrote my PhD thesis, this was a bit what we wrote, like 10 to 15 years, prices will drop and hyperspectral will be everywhere. Yeah, sure, we have hyperspectral satellite data, but we still don't have the airborne data. Combining the LiDAR with the satellite data might still be possible, but then I think the scale mismatches is quite big. I mean, I'm not so sure whether this makes a lot of sense.
Okay, I understand the scale mismatch between LiDAR data and hyperspectral remote sensing from space. But if we would have very high resolution data from drones or even very close range information and bring that together in a model, wouldn't we understand much more? And then we could extrapolate this to a larger area?
Well, I think this is a very good point. I mean, you can use detailed radiative transfer models to really simulate signals. And of course, in order to check whether your simulations make sense, it's very valuable to have this very high resolution data from drones and from TLS or airborne laser scanning data and so on. Yes, I agree. And I think this is really interesting for being basically able to model a realistic signal. And this can really help to understand what is happening. And I think there is a certain chance of that this could also be used for improving an area-wide mapping from a satellite data, because in theory, I mean, there have been these approaches where you just use a lookup table. So you use traditional ones, you use ProCell, you simulate thousands of spectra, and you just check, okay, what is the match between my satellite observation with these spectra that are simulated, and if you have a good measurements from your satellite, and you might be able to get a certain idea what is going on in that pixel. And yeah, I mean, if you have a really good radiative transfer models for forests, which they do exist, I would say, they are maybe not yet perfect, but they do exist. You might think about going in such a direction. I think the potential problem is still that the variability is just too high. That there are so many things that influence your pixel at a 30 by 30 meter scale that you would get so many solutions for your one spectra that it might actually mean very different things on the ground. So that it's still challenging.